Okie dokie. Well, I'm glad everybody is here. I know most of you are going to be on YouTube. We don't have too many in the Slack channel or the Zoom channel, but we're going to go ahead and go anyway. So today's talk is about SQL. SQL 101 is what I'm calling it. And what I built is a set of scripts that you can actually walk through and learn about SQL. So here's a URL. It's right off of my website, but you can download it. It's about 45 megabytes. It's not really huge, but too big for just an email drop or whatever like that. So you can run this on Windows. If you run it in the Windows subsystem for Linux, just pop it up in like a bash prompt or whatever like that. I'm running it currently on a MacBook, or you can run it on any Linux platform. All you have to do is make sure that you have installed the package SQLite 3. So tar xzf SQL. All right, so it comes with just a bunch of files. One very large one, about 250 megabytes, and that's the data set itself. And then a README file and a bunch of scripts. So let's go ahead and look at the README file. So what I'm going to do is I'm going to actually execute SQL commands and explain them as I go along. And with that, you're going to learn, hopefully, how to do SQL. The data set that I'm pulling this from is actually IMDb. That's the movie and TV database of all the TV shows and movies that have ever run. It's an awesome database. And I've only got a very small portion of it. And according to the rules of IMDb, I'm just supposed to record or give you this copyright information here. And I'm very thankful that they've given me access to it. Now, any of the scripts or whatever is covered by the beer license. You know, just do whatever you want with it. Okay, so the first thing we do is we could run me. Then later we have two other SH scripts that you can run. So again, this is a repeat of the information. Thanks and all to IMDb. And so what I've done is I've actually taken the IMDb database, or part of the IMDb database, and I just totally screwed it up. I made it as the worst and most inefficient way that you could possibly organize this really good data. And what we're going to do is I'm going to show you basically how to query it once I've installed it, and then I'm going to show you how to rearrange it. And all of these things are going to be done in the SQL shell, the SQLite shell, so you can actually watch the SQL commands happen as I do them. They are driven by a script, so you just run the script. And then if you miss a step or just need to start over, just start that script over and you can do it all over again. It clears the slate every time. So anyways, looking at the data, I went in and I looked for all TV shows that have their title like that, where it says episode date. First of all, guys, is this too small to read or too big or whatever?
It could stand to be a little larger.
Okay, let's do that. All right. So let me just get it reorganized there. Okay, good. Now, I chose all these TV shows based on that criteria. And the reason I did that is I'm going to later do some date arithmetic. And this is basically, these are odd TV shows, like you're going to get like the Joey Behar show or the Tonight Show or something like that, where they're not actually titled shows or episodes. The show is titled, but not the episode itself. And I'm going to use that to say the date that it was aired. So the data is basically, it's going to be the episode title, the show title, the year that it was shown, the role of this person here, and the birth date, and if I have it, the death date. And these two are IDs of the episode and the show that actually come from the properly organized data, and I'll be using that later on in the demonstration. So this is mostly it's not even the full data set, but it's still 270 megabytes. It's large. And I'm going to go ahead and put you guys in, or actually I'm going to act in the role of a DBA and put you in that role. DBA is a database administrator. So let's talk about SQL first and foremost. It's pronounced SQL, as in like in a TV show, a sequel, and it stands for Structured Query Language. It was actually invented in the 1970s, and in the 1980s, IBM adapted it for their DB2 or other mainline database products as well. And this is ancient technology by internet standards, but it's solid as a rock, and it really, a lot of websites, especially websites, use SQL as a backdrop for all the important data that they use. And so having knowledge of SQL is a critical component in your resume. So anyways, there are many databases out there. I'm just going to name a few here. MySQL and MariaDB, PostgreSQL, Oracle, SQL Server, DB2, and of course SQLite, which I'm demonstrating today. SQLite I chose is because it's super light. It's actually just a library, and then they have a bunch of command line tools that can connect to it. In reality, every one of these databases have GUI components. I'm not using GUI. I'm going straight command line, mainly to show you the ins and outs and the innards and all that fun stuff. I personally prefer PostgreSQL as a heavy lifting database, but Oracle and SQL Server are battleships. They're just awesome, but they cost an arm and a leg, especially for support and management. But you can't go wrong with those two databases. Now, my mother was a DB2 DBA, so I get it in the genes, but I've not personally had any exposure to DB2 directly. So, okay, the first thing I do is I'm going to clear the screens, and what I'm going to do is I'm actually going to import that dataset.csv. It's a CSV, like if you were going to import it into like an Excel spreadsheet, I'm going to import it into a SQLite database. So what I'm doing here is I've executed the command pragma, because I'm just using this pragma, and I'll be using that all over the place. And I'm telling it to be in mode CSV, and then import the CSV file into this table called episode people. Now, as you notice, it took a long time. While I was talking, it was parsing all those 270 or 200, I don't know, however many megabytes it is. And it's about 2.5 million rows of data. So in that process, I then executed at the end, I say dot tables, which is a command line tool to show me all the tables. And it's just the one, episode people, because that's the one I asked it to import, because it was a blank database when I started. And then I executed the command schema to show the actual schema, which I'm not going to go into details right now, but suffice it to say that when SQL, when you ask for a schema, it's going to give you the actual SQL command that you would execute if you wanted to recreate that table. And so after doing that, I'm going to do a trivial query. We'll go into the query in more detail later, but basically it's just showing it out just like it were in that CSV table. You're going to have the episode, the show, I'm calling the column date, but it's really just the year. You're going to have the role of the person, the birth date. I'm not going to get that to go away. And then the birthday, the death date, and the IDs. Then I executed, I counted all the rows in there, and there's 2.4 million rows in this data, in this table. That's not huge. Like I said, it's 250 megabytes, 270 megabytes, whatever it is. And that is not huge. I'm doing this on a MacBook Pro. It's not the fastest computer out there, but it's a good one. And it can do things in less than a minute, but in reality, in most of these databases that you're going to use, like Oracle or Postgres with, could be terabytes in size. And this is trivial in comparison. Okay, so I've imported the database, and now I'm actually going to go into doing the first section of data. Okay, so we're going to first look again at the data. I showed you the commands for SQLite, and that's dot tables and dot schema. Doing it again, and it's showing you dot tables is showing you that I have only one table, and that's episode people. And the schema is, again, as I said, it's an actual SQL statement, but shows the different rows or the columns in the row. You got episode, show, date, etc. So here, when I type schema, it would have actually given you all the create statements for all the tables in the database. But since I only have one, it only showed me the one. So I could actually say dot schema and just the name of the table itself, and it's going to show the actual, just that one table's creation statement. So now, what's up? So again, as I was saying, is when you ask for the schema, it's going to give you in the form of the SQL statement. So let's go over what I've done here. Is when it did, when SQLite imported it, it actually did all this stuff on an automatic basis. I didn't control it. I could have controlled it, but I'm just going to let it do its automatic thing. And what it's doing here is it's saying the first column episode, and it's going to be of the data type text, okay? Show, and all the items here are of that same data type text, which just think of it as a string, okay? SQLite doesn't have very many data types. It's, like I said, it's a small footprint database, so it only has like 4 data types, and that's going to be integer, real, text, and blob. I'm not going to go into blob today. Integer is just the numbers, accounting numbers going back into negatives. And real is going to be, you know, like floating point, stuff like that. And text is just strings. Blob is actually binary data. We won't go into that. Now, even though I can't really show you car and varchar, if you were using any of the other databases, you would be using probably instead of text, you would be either using car or varchar. And what car means, like if I had set instead of text and said car 128, that would have said create that column as a string of 100 up to and including 128 characters. And then varchar is actually the same thing, except car will do it as a padded string. So in other words, it'll always consume 128 bytes. And when you return the data, it will always return you 128 characters. But varchar will store up to 128, but if it's less than 128, will also return you the actual number. Say it's 45, it'll return just the 45 characters in your string. But you'll use that one probably much more frequently in all the other databases than you will any other data type. So keep that in mind, but I can't really demonstrate that for you. I just wanted to show it to you. So let's go ahead and talk about a select statement. 99.9% of the time, what you're doing is you're in SQL is calling select. Select is basically just querying the data for a report or query the data so I can look at it or whatever. I want to see data organized in a certain manner. And the way I do that is with the select command. Select command can look odd, especially later on when I do show you some very complex select statements. But in reality, it's structured pretty simple if you do a simple one. It gets much more complicated, of course, when you do a complicated one. So select is the key verb. Star means return to me from the table all the columns. And I'm going to say get the data from the table called episode people, which is the table I just created a few minutes ago. And then the where clause is find me all the rows in that table that meet this criteria. And in this case, it's the one just means give me all the data. So in reality, I've set up a for loop if you're a programmer and just gone through the whole table, one row or record at a time. But then I'm also going to, instead of returning the 2 million rows, I'm going to instead say, just show me the first 10. And that's what limit means. Now, I'm also using, what do you call it? The word escapes me right now. But what I'm going to always use capital letters to describe SQL language element names, whereas table names and column names, they'll be of mixed case. But anything that's of the SQL language element or verb or whatever is going to be in capital letters. This helps you, and it's a context that everybody or a good portion of the people use because it makes it very clear in when you're reading the statement what's what. And so that's what I'm doing here, and I've been doing that for 30 years. So I say select all those items, but only show me the first 10, and there you go. It's pretty simple. And because I said mode columns here, it's going to show all the data in columnar format, and headers on means it's showing this right here. Now, these two are commands specific to SQLite, but almost all of the databases have a command line tool like SQLite and would have similar commands, but you'd have to look up the syntax and flavor. So let's go on and do some more here. Like I said in the previous example, I said select star, which meant show me all the columns. In this particular case, I'm only going to show you the one column, and that is show. The one of the columns name is show, and so there's going to be a lot of repeated words there, but forgive me. But I'm still going to do one item from that one table, where one, and instead of limit 10, I'm going to show me 25 of them. And there you go. Now it's only showing the one column because I only asked for the one column. And the reason why you would do that in, when you're just poking around in the database, you're going to be lazy and you'll say select star, just show me all the columns. But when you're actually writing programs and websites and stuff like that, you want to use targeted columns, exact columns you want, because that way you can minimize the data that's transferred. Because in reality, on most of these databases, but SQLite, you're actually transferring this data across a pipe or a socket. And so there's data transport time. And so you want to minimize that data transport, minimizing the data transport time as an extra cost in your transaction. So next I'm going to go on, I'm going to do some more complicated things here, because when I showed you that earlier, the shows were duplicated because we're going to have lots of shows. And in this horrible way that I organize this data, it's heavily repeated. But I don't necessarily want to see all that type of data. I just want them grouped by. So in other words, instead of showing me 10 shows, show me one show, okay, because I'm going to group it by. And so you'll only see the show name once. But I am going to take advantage of it and say count the number of shows by that name. I know this is where people would ask me questions, and I apologize since we don't have too many people in the chat. They can't ask me questions, but we'll leave information where you can ask me questions later. So I go ahead and I hit the command. Now it's slow because remember it's a large database and I haven't organized it properly. But here, this is a show name, and in this database, it only appears 3 times. This show, Lake Show, appears 77 times. This one here is probably another language, maybe French or Italian or whatever, appears 325 times. And we don't have control in the SQLite here, even though I said columnar. I'm not telling it how many data, how wide to show it. That's a function of the command line program. And so I can't control that, but I know that those strings are much larger. So it's cutting off bits and pieces of those string names, or show names, excuse me. So going on, in the previous one, I showed you here count show. And in the previous one, it showed in the column name count show, okay? I don't think that's pretty. Actually, I think that's ugly. So I'm going to take advantage of a feature that I use all over the place in SQL called as. And what that means is, in this particular case, is I'm going to return the data count show like this. In other words, count up all the shows by that name. But I'm going to, in the column, and if you were a program and you would read it as the word count here. But everything else listed here is the same. I've only renamed that column. So think of as renaming. So when I run it, it shows the same data that we saw in the previous run, but the column name here is count. And that's probably more significant for if you're writing a Perl program or a C program or whatever, and wanting to extract that data from the data stream, you would extract it with the column name count. And that's a good use for the as modifier. Okay, so now what I'm going to do is I'm going to sort, okay? That data was ugly. It wasn't very intuitive or anything like that. So I'm still going to return count as, so I'm still going to call it count, but I'm going to sort it. And the way you sort it is with a statement called order by. Order by means sort by or order by. And it always comes up in ascending order by default. We'll play with that later. And I'm asking for the second column here. Notice I put the number 2. Most of the time you're actually going to put the name of the column, but for right now I'm doing number 2 so I can show you this. I don't even use it very often, but I think it's useful to show people. But everything else being the same, the data is going to be different because now I'm sorting it. Okay, so it's actually sorted, you know, in numerical order, and I guess the pound comes before the number 1, and so on and so forth. So that's pretty cool. Next, we're gonna also order by, but this time I'm going to order by the column name. And in this case, remember, I had renamed it CountShow to count, so I can use that right there as what I'm sorting by. Now, I could sort by multiple columns, but there was no useful way to sort it in this particular state, so I didn't do it. So we're just going to go with the first one, and it comes up with exact same data as the previous run, because the only thing different is how I called that column, but I'm referencing and sorting by that same column. Next, right, now instead of, like I told you that when I do order by, it defaults to ascending. That is, the lower number is first, going higher and higher and higher. Well, you could say I want it in the other direction. I want the highest number first and go lower, lower, lower as we go on. So I'm going to now put on the modifier desk or descending. You could actually probably spell out descending if you could spell it all right. But desk is all you really need. And ASC, which I'll show you in a minute, is the ascending equivalent. So this one's going to take longer because it had to go through all the orders also. But you can see the EastEnders, which I happen to know about, is a British TV show. And they have 50,000 entries in this data set. Telediario, I don't know, it's probably Spanish, has 36,000. The Today Show, which is a US show, 27,000. The Tonight Show, 24,000. And that's all that's in this database here. And the database I have here is not a complete one. So, but as you can see, I've ordered it in a descending pattern. So now we're going to go ahead and do the same thing. Remember, I told you order by defaults to ascending, so you don't have to type ASC. But in this particular case, I am going to do it, and it'll be the same as the first entry or the first run I made in that thing, where it's ordered, but in ascending order. And like I said, I didn't even need to say ascending, but that's what you would do if you wanted it in ascending order. So I'm going to go now throw a bunch of queries at you one at a time, and we're going to just show different aspects of this. Okay, so let's go back up here. Okay, completeness. All right, so it's going to be right here. Sorry. Okay, so the first one here is select episode. Now I'm going to use the episode record or the episode column from people, but I wanted to say where the show column is the word telediario. Okay, I'm horribly pronouncing that. I apologize for whatever that language is. to the people that speak that language, but I'm doing the best I can. And anyways, so giving me the dates of the episodes, the first 10 episodes that's in the database where the show name is Teledario, okay? The next here, I'm doing very similar, but I'm grouping by episode and then ordering by the first column, which is episode in this case, in descending order. Now it's kind of weird because we're talking really descending is going to be in alphabetic, so don't think about the numbers, think about it in alphabetical order. But you can see right here, it's in a descending order goes. It just happens that these numbers fall in a descending order. Next, less interesting, but I'm looking at the count again of the episodes. So with the, I'm going to say for all the show called Teledario, group by episode and sort by the first column, which in this case is the count, in descending order. So in other words, the highest will be the first one I see. And I'm showing it just the count. So all you're going to see is a bunch of tens because apparently there were only 10 episodes of those particular names in Teledario. And in the last one here, I'm selecting episode and count, Teledario, group by episode, order by the count, okay, descending, and as you can see, it's choosing because remember, it's doing all these things because, you know, you can see it's really alphabetical ordering, but there you go. It's sorting in descending order. Next, I'm going to show you about like. Like is really cool and you'll use it a lot. It'll slow your queries down something awful, but it's very powerful. Most databases also have a regex thing if you're a Perl person. But people usually just use like because it's a pretty simple thing to search on. So again, show and person from the data set, from the table, people, where person is like this statement right here. And what is going on here is just think of the percent sign to be a star right here. So it'd be kind of like if you were looking for a file name and saying ls f star, and it'll show all files that begin with the letter F. And that's very similar to what's going on. So think of them, yeah, here it's a wildcard. So you can have anything in front of Fred or anything after Fred, but it has to have Fred A in there somewhere in the name of the person. I'm actually looking for Fred Astaire, but we'll see what shows up. And I grouped it by a show also. So actually this is, I didn't limit it. So that's everything there, all the Freds, Fred A's in there. So we got Alfred because it'll allow everything before the letter Fred. Apparently it's case insensitive search, which is good. So it's allowing Al in front of Fred and anything after, so Venton here, but then you have Fred Astaire, which has nothing before the Fred, so that percent can be nothing as well. And we got the same thing with Fred Armisen and Winifred and all these others, and they all fit the criteria for this like statement here. So, I mean, it is very powerful for looking for strings. It's actually probably faster than a regex, but we'll see. I'm sure somebody will argue with me on that one. So next, instead of searching for the like, I'm actually going to search for Fred Astaire, group it by show. So actually right here, Fred, the person equals Fred Astaire, and group by show. And there aren't that many entries here. It's what 10 or 12 entries here, and different shows that he was on: the Dick Cavett Show, the Late Late Show, the Tonight Show, the Today Show, whatever. He was, you know, a movie star from the 1940s and 30s, very popular, and I just happen to know that person's name. So next, I'm getting more data, the same basic criteria here, group by show, Fred Astaire, but I'm showing more data. Show name, the date, which again is the year it was shown, and Fred Astaire, and so on and so forth. Next, I'm going to do something, one of my favorite, it's probably second favorite games I like to play in SQL, and that is in. So something is in a list. A lot of programming languages will allow you to say for each in a list and do that. Well, this is very similar to that. So I'm saying in this particular case, find all persons that are in this list, which in this case, the list is Fred Astaire and Fred Allen, group by show. And here we go. It's, you know, just Fred Astaire and Fred Allen, but it's all the people or persons in just that list. I love that. And I'll actually pipe SQL statements into our select statements into select statements using that type of form. So now I'm going to show you a slightly more complex select statement here, and I'm going to show you another convention. That's the word I wanted to use before. Well, the convention I was showing you before is that we use capital letters for the SQL language elements, but on the case of a complicated select statement or a complicated SQL statement of any sort, is you would organize it in this manner. You'd put the language element here, the value for that language element there, then another language element and its items, and then, oops, that didn't work out well. Okay, and then the next one, and you can see it allows you to understand the SQL query much better. And so if it's more than just a trivial query, I recommend using that form. You know, it's just good practice. So what am I doing here? Yeah, I told you about that in statement before. Well, here's another way to do in. You don't necessarily have to say from a table, okay? You can say from the output of a select statement. So in other words, I have this relatively simple select statement, which I showed you before actually, and it's the episode and count as the column count name, okay? And I'm renaming this element as A. So from this data set, it's not a table. It's actually a form of view, and we can argue about the semantics. Advanced SQL would have things like views, which are basically just select statements, but I'm not going to go there right now. So this whole entry is A. So return to me in the select A.episode, which is the episode here because I'm naming it A. So A.episode is qualifying this data set, an episode, and A.count because I renamed it count here. There you go. And then I'm going to order it by A.count in a descending manner. And this actually is not significantly different than the previous set of ones. It just shows it in a much more complex manner. And you're probably going to need to study that one a lot. And so one of the advantages of the way I presented this information is you can actually pop up this database in SQLite and you can play with that SQL statement right there until you understand it. And that's the beauty of this download. So let's look at the output. Not particularly different. I don't even think it's different at all than what I previously showed you, but I just did it in a different manner. And just like in a lot of different languages, you can actually get to that same spot in multiple different routes. And I just chose a very difficult route to get to someplace we were before. So now what I've done in this previous section is I just showed you many different types of SQL statements and what you can do with grouping, what you can do with ordering and grouping by, ordering means sorting. I showed you good form on how to form your SQL statements where we use the convention of the uppercase letters for the data or the SQL elements. And I also showed you in a complex SQL statement using the form of on different lines, using the SQL language elements as a different line segment right there. Those are good practices. I highly recommend you adopt them early rather than later because it'll make your life a lot simpler when you go to make much more complex statement. So now we're going to go on to the second section. I've already done runme.sh and section 1.sh. Section 2.sh is much larger, but it's the last of the sections that we're going to go through. So what I'm going to do is the database that I had previously created and did all that querying in was called tvepisodes.db. And I'm going to copy it to a new version of it called tvepisodes02.db so I can actually start manipulating. I'm going to actually start changing data in the data set. And so that way you could always go back to TV episodes and do straight querying without having all the manipulated data actually changing stuff out from under you. So it does that CP command. And one of the things I'm going to talk about is the normalization, which is the term that databases have used for decades. And a term that we use in programming often is called deduplication. That is to remove duplication. Well, normalization in databases is basically the same concept. We're going to simplify the database by removing the duplicated data. We're not actually removing it, we're just transforming it. So we basically have one source of truth for each data element. And if you go look up in the literature, you're going to see things like the first normal form, the second normal form, and even the third normal form. I don't know if there's any normal forms beyond that, but I'm familiar with those three normal forms. I'm not going to discuss them here. Go ahead, look in the literature, get proper definitions. But this normalizations I'm doing now will give you the background you need to understand what first normal form or second normal form or whatever is. The goal of this process is, I told you, I totally butchered the database that IMDb had. They actually had it properly organized well, it was efficiently organized, and I made it so inefficient, it's just horrible. I'm going to now, before your eyes, I'm going to go and I'm going to transform it into an efficient data form similar to the data as if you had queried it directly from IMDb. So here's just a repeat of what I had done before, show you the schema, the tables, and the first 10 entries in the data set. And notice that we got episode, a lot of duplicated there. You see show name is duplicated here. Person's name are not duplicated in the ones I'm showing you right here. But if you looked over the 2 million rows, you're going to see persons are going to be duplicated. You'll also see rows are going to be, a role are going to be duplicated. So over the next period of time and the rest of section 2, we're going to go ahead and normalize this data by looking at removing some of that duplication into separate tables. So let's go on, and I'm going to call myself a prestidigitator, and that's a fancy word for magician. And I'm going to transform this data right before your eyes, and hopefully you'll understand what I'm doing. But let's start with the create table statement here. So I'm actually going to do this by creating a second table and extracting data out of the original table and putting it into the second table. And I'm calling this second table episode manip, okay, or manipulation. I would normally do this in a temp table. So I would say create temp table and then so on, in the sense that if, because the moment when you say a temp table and you create a temp table, the moment you disconnect from the database, that temp table disappears. It's not a permanent record. It's only live during your session, and no other sessions can actually see your temp tables. But in the way I've structured this script, I'm actually connecting and disconnecting, connecting and disconnecting. I can't use temp tables in this demonstration. So I'm going to actually use regular table manipulation statements and then make sure that I do a cleanup at the end with a drop table. And we'll talk about that in a moment. So anyways, what I'm going to do is I'm going to pull some of the episode information out. But remember, I showed you a moment ago the episode name. And we're going to put the episode name here in title because it's the episode title. And I'm going to take the episode ID, which was actually one of the last columns in the database. And I preserved that from the IMDb database because it was just going to be too difficult to do it otherwise, but I've done that. And so thank me for that later. And date is going to be, it's eventually going to be the actual airing date and not the year as the date column is in the actual episode people. So the way I'm going to do it is I'm going to first create the table as you see it right here. We have the 3 data types. It's going to be the episode ID, the date, and the title, and they're all going to be text records or text columns. And then I'm going to run, this is actually one statement right here. And notice the semicolon at the end. I didn't actually mention that before, but SQL has semicolons at the end. Sometimes you don't need them, but just do them, it's good for them. So what I'm going to do is I'm going to insert into the table episode manip the 3 columns, and I'm identifying the 3 columns I'm going to fill or populate in this particular statement. And I'm going to then populate them with the output of this select statement. And notice I've got 3 columns here, and it'll match the 3 columns that are here in that order. And that's very important. And here, the rest of the select statement is I'm actually saying where one. In other words, give me all of the data. I'm actually going to snarf all of that data in there, but I'm going to group by episode ID. So in other words, I'm going to get unique episode IDs in this episode manipulate table, okay? So I'm going to deduplicate a lot of the rows that way. And then furthermore, I'm going to fill the date column with the same as the title column. And I'm going to do that because I'm going to extract the date out of the episode title name right before your eyes. But for now, I'm going to fill it initially with the episode title. Then for sanity's sake, after I finish, I'm going to count the 2 tables. I'm going to show you the number of entries in the episode manip table, and then I'm going to show you the number in the original episode people table. Notice I am not modifying episode people. I'm only modifying episode manip. So I'm not changing episode people, so that count should remain the same. So it's actually executing right now. Notice it takes time because there's a lot of data to go through. So notice I didn't show this earlier, but here's a command that I'm putting in there because, well, for safety's sake, I want to create the table, episode manip, but I want to say if it existed, say I disconnected or something like that, and I hadn't finished, I could say drop table if this table already exists, so that I would actually not have a table present, and then this create table would happen. I could have also said create table if not exists, but then the drop table always guarantees me I'm going to be in a clean state. So I create the table as I showed you above. I executed the insert statement right here with feeding it in with the select. Then I get the count of the rows in the episode manipulation table. And notice it's 564,000, whereas the original table has 2.4 million. I've reduced the number of information, or I will once I've removed it from the episode people data table, but I'm right now, I'm not going to do that. I'm going to go ahead and I'm going to work on something a little bit different right now. Because the data form of the title name, which is actually now in the date column, because I just created that date column, is going to say episode dated 6 March 2003. Now, keep in mind that this number there could either be 6 or 12 or 24 up to 31, or just 1 digit or 2 digits is the point I'm going to make. So I'm going to run multiple commands here to transform that data one step at a time so that it's actually going to end up in a form much like this, where it's going to be the 4 digits of the year dash the 2 digits of the month, the 2 digits of the month dash and the 2 digits of the day. And the reason why I'm going to do that is because that is the form that SQLite uses for its various date manipulation functions. And we will demonstrate that as actually the last thing I do in this demonstration. But you can actually do arithmetic on dates and stuff like that, but it has to be of that form in order to do it. So I'm transforming that date one step at a time. So let's look at these things that I'm going to do. I'm going to actually run about a dozen, 2 dozen update commands, which basically says update the episode manip table, setting the date. Okay, so I'm actually going to go through all 564,000 records in the episode manip table, and I'm going to do it 2 dozen times or whatever. Okay, and on each statement, he's going to, the function, this is a SQLite function called replace. And the way that works is looking at the column named date, if it's of this form right here, so in other words, it sees dated 1 space inside the column. Now that's kind of like the like statement. So in other words, anywhere inside that string of that date column, it sees that, it's going to replace it with this. So it's like a search and replace command, although it's just called replace. So think of it as search and replace in your data editor or in your text editor. So I'm going to do, first I'm going to, anything that's dated 1, that is, it's a single digit 1, single digit 2, 3, 4, all the way up to single digit 9, I'm going to change them to the 2-digit equivalents. And that's for later on when I do more sophisticated string manipulation, it'll always be 2 digits. Then after I run that through, then I'm going to do a replace on all the records in there. And I'm going to say, change episode dated space to an empty string, or no date at all. In other words, I'm going to search for that data or that string and replace it with no string at all. So in reality, it's going to just say 01, 2003, 02, I mean, whatever that comes to. And then furthermore, I'm actually going to continue editing. I'm going to change the month names that are going to be in those strings, because remember, it's going to be like March is in the middle, and change them to the 2-digit equivalent of those months. And so that alone is going to get it without the date, the spaces between, or the dashes between them. It's going to say 06, 03, 2003. So after that, I'm going to make sure that the data is good I'll execute these 2 commands. And if there's any output from those 2 commands, that means I missed some data somehow. So it's more of a sanity check. And what this basically is look for any data, any dates in the table. And if the length is greater than 10, actually this one would have been sufficient actually, and say, if the date is anything other than 10 characters long, then I did something wrong. So it has to be exactly 10 characters wrong, or 10 characters long, or I did something wrong in this arithmetic here. So it'll be, like I said, 06, 03, 2003, which is 10 characters. You can actually see right here, I put it down in comments, a way to look at what that's going to look like. And then finally, the last statement I'm going to do is I'm going to concatenate data. I'm going to extract data and concatenate it. So again, I'm going to pass through every row of the episode manip table, and I'm going to reset the date value to be substring. In other words, get me the sub part of the string starting from the 7th digit and get 4 digits. And then this is the concat character. So concatenate this string with that one, and then get me the substring of the date starting from the 4th character, getting me 2 characters long, and concatenating a dash in there, and then getting me the date from the 1st character to for 2 characters. And notice, as painful as this is, I'm a programmer, so arrays start at 0, but in SQL, arrays start at 1. So that's why if you look at this, this is what I would actually do if I were programming it in Perl or C or whatever. And I would put everything as 0 based, but in reality, it's 1 based. So that arithmetic, keep in mind, is 1 based. And that should, after I run, should do all that. So watch it do its thing. Okay, so it did its sanity check. It didn't get any data from there, so we know we did all the manipulations correctly. We did the final manipulation, which organized it so the dates look like this. And you can see that the dates are formatted in a way that SQLite can actually do data arithmetic on it. And that's only 20 records in there, so there's a lot more. But we still have the full title in there if we wanted it for whatever reason. But we actually have a real air date in this data table. And that'll actually be good later on, and I'll show you later. So now let's go on and do some more. What I've done is I created that episode manip table, as I was showing you before. But I made it as just a temporary table just to do some work. Well, now I'm going to make the permanent table that is basically the same data that I got in the final version of episode manip, but I'm going to organize it in the proper manner. So look at how I've done this. I'm going to have the same create table command. I'm going to call it episode dates. And the first entry is called episode ID. It's a data type is text, but it has something called primary key. And I've not talked about that before, so I'm going to talk about that now. In all our DBMS, that's Relational Database Management Systems, databases, Postgres, SQL Server, whatever, all these are RDBMSs, which is different than the NoSQL databases, but I don't want to go there. But in all our DBMSs, you typically have what's called a primary key. And that is, it's a unique entry for every row in that table. They have to be unique. It'll actually give you an error if you try to add a row to that table with the same key as some other row in that table. It'll actually give you an error. So it guarantees you uniqueness of every episode ID in this particular case of that column in the table. So you can then later on and do manipulations on that exact row using the primary key. And we won't do that just right now, but that comes in handy when you're doing manipulations. And then we have the rest of the data, title and date and title. So I'm going to do it in a manner similar to the way I did it when I created episode manip. I probably broke my promise to do it the same way every time, doing it in the proper best practices, but it's essentially the same thing. So I'm basically just feeding the exact form of episode manip directly into episode dates, because in reality, I'm not transforming any of that data. I'm just going to just transfer the data over and eventually throw away the episode manip table. I don't need it anymore. So then I'm going to do two other things in here, and I'm going to create indexes. And what this basically does is it's an index. It sorts. It doesn't sort the actual data. It creates an index of sorted data on, in this particular case, I'm actually sorting on the date, and in another entry, I'm sorting on the title. And so what that basically means is I can get titles in sorted order real easily because I'm keeping an index, a sorted index of that title. I'm actually going to use it for dates later on more than I'm going to do it for anything else. But it allows me to access the data in a much more efficient manner. I may not be able to get into that in much detail, but index often. It only hurts in the amount of data space it consumes on disk, and it does cost you more when you insert data. But when you query data, it's your best friend. So there are, just like with any type of engineering trade-off, indexes are the bee's knees, but they cost also. So keep that in mind. Then after I'm done with creating all these indexes and doing all these things, I will drop the table episode manip, basically deleting that table because I don't need it any longer. And then I'll show the first 10 entries from episode dates. And there you go. So it's basically the same as episode manip, although now I've got it in a proper form where I've got the primary key in there. I've got the indexes created. So that's in a good form. I've improved it. So now, again, I'm going to use, because these are going to be much more complex SQL statements, I'm going to use the complex form to make it easier to understand and explain. But what I'm going to be talking about is called joins. It is the lifeblood of SQL. It's the most powerful feature of SQL. You will use joins probably more than you will use any other feature in SQL itself, because it's just what you need to do. And you'll see later on when you start using SQL that joins are what you need to know. And so I'm going to go into a little bit of detail of different types of joins you're going to use later, but just keep in mind that a join means I'm taking two tables, in this case episode people, and this episode dates, okay? So let's talk about this first statement here. I want to get this information from episode people, but join it on episode dates where the criteria of the join, that is how these two tables are related, or the rows in those tables are related, is by this criteria. And in this particular case, I'm using episode ID because I have it in both tables, episode people, and I have it in episode dates. So I can say the episode IDs must be equal, and then get me the persons by the name of Fred Astaire and Fred Allen. Now what this does is, when you're thinking about a join, I couldn't really come up with a good way to put it in a text screen like this, but think of it as using that join criteria, the on statement there. I'm taking the data from both of those tables, and when I find the criteria where the two rows match, I put the two rows side by side so I can access both rows at the same time as if they were one single row, okay? So further with that is I can then pull data from the two different rows. Like if I want date from episode people, I say episode people dot date. And if I want the episode dates date, I say episode dates dot date. And you remember the episode people dot date is actually just the year, whereas episode dates dot date is the full date of the day it was aired. Now show only is in the one table, so I can say show all by itself, okay? But in the case of date, since it was in both of the two rows, that even though they're side by side, if I had said date there, it would have actually given me an error because it didn't know where to get the date from. So here I'm telling you, or telling it, to get the date from the episode people row, whereas this one, get this date from the episode dates row. In that case, I'm also going to further rename it as the real date because that really is the real date, but I will go in later and we'll reorganize it. Then in the second one is a very similar one, but I'm using my favorite as in the case of the table names. So I can say, instead of having to type out episode people here, I can say EP dot show or EP dot date. I love that feature and I do that all the time. It just makes it so much easier for me to qualify data without having to type long entries like that right there. As is just so cool. And you can use it like everywhere, and I use it everywhere. I just love it. So again, we're going to do our criteria based on episode ID, and notice I'm using the as name right there, and the same criteria of I'm looking for Fred Astaire and Fred Allen. And then here's a third one here. What am I doing differently here? So I'm not sure what I'm doing differently here. Oh, I'm doing the group by show. So that'll show data a little bit differently right there. So let's go see what these result in. Oh, It didn't actually show it. Oh, well, I may have made a mistake and I apologize. We probably will be running those again in here a little bit because I'm sure I showed those. I'm just a little out of order. Anyways, the concept of join in the sense that I use it is almost always the same type, but there are 4 or 5 different types of joins, and those are all very oddball or very specific need cases where you'll use the other forms of join. Suffice it to say that you're going to use inner joins, I believe is the proper term for that. I may be wrong on that, but that's the one you use almost all the other time. Oh, here's the other ones. You can do outer, left, right, and cross. I know what left and right are. I can't remember what cross is, but you have to go. This article here talks about it. You can go to that article, but you can go to any place in the literature out there and Google and get definitions of these different types of joins. But I can guarantee you, unless you have a very specific scenario where you need those other types of joins, you probably won't be using those joins. I can probably count on one hand the number of times I've used a right join. So just keep that in mind. Okay, okay. So I just basically repeated a lot of that information there. So here's the first one here I talked about before, where I'm actually using the long form name. I described it earlier. So it's episode.date, and I can distinguish it from episode dates.date or from episode people.date, because remember, there are 2 rows are side by side, and they both have the same name for that column date, so there would be confusion. It wouldn't know what to do, so you have to qualify them in this particular case by the actual table name that you're getting it from. But we're getting it from episode people, joining on episode dates with the criteria where the episode IDs are the same. And we're looking for Fred Astaire and Fred Allen. And there's the output there. Notice that the column name here is real date instead of date, because again, that would have caused confusion if you saw a date here and real date there, or just date there in the 2 different columns. So that's one of the reasons why I renamed it there. So the next one I went over, I used the more simplified, or using the as, where I renamed the actual tables. And so I can then qualify on the shorter name, ep.show, ep.date, ep.person, and ed.date as real date. I just love as I described before, but everything else is the same. Search for the people, Fred Astaire and Fred Allen. And the criteria, again, is episode ID, again, using the qualifier in the simplified name. But that would be the exact same date I just showed you just a moment ago. So going on to the next query, the only thing different I'm doing here is I'm grouping by show. So the date is going to be a little bit different, but we still got the Fred Astaire ones, but we don't have a lot of duplicated data here, because if you look at this one above, you can see the Tonight Show several times, but you should only see the Tonight Show once in this set because I grouped by show. It may not be correct because the show by date, the actual real dates, this was this was 75 in October. This one, here's the other one. This was 75 in May. So, group by, you have to be careful when you use it, but it does reduce the amount of things here, but it doesn't give you the perfect answer. You got to know when to use it, how to use it. So we're going to now, I'm actually going to go do a true deduplication or a true normalization. Because since I've moved the episode title into the episode dates table, I'm going to remove the episode title from the episode people table. And I can't just say, there might be some databases that will allow me to drop a column, but most don't allow you to drop a column. So we're actually going to have to create a new table with a new schema with notice there's the episode is not listed in this schema because I've moved it off to the other table. So I'm actually now, as I said earlier, I'm going to actually remove the episode title from the original table. And so I insert the data, using this complicated statement here. So I'm going to insert show data row person birthday, death day, episode ID, and show ID. And it's going to be the same as in the select statement here from episode people, where one. Okay, so once I get done with that, I would have populated the new episode people table. I can then delete the old episode people day table, and that's drop table. I'm going to then rename the new episode table to the episode people table so that it's now going to be called episode people again. So let's go ahead and watch it do its thing. And there you go. So notice that episode title is not in the data set. And I can get to the episode title through the episode ID, which is conceptually called a foreign key, which I'll introduce later. But just suffice it to say, I can use this to get access to the episode title in the episode dates table at any time. So there was actually no need for that data in this table here. And that's why we did the deduplication. So let's look at the join again. In this particular case, I'm going to say, I'm using my favorite as, episode people, join on episode dates where the episode IDs are, but I'm going to show the title now from the ED table because it's no longer in the EP table. And just show 10 of them, and I'm going to group it by show. It's a little slow because I've got badly organized data. It'll get better and better as we progress. But here, as you can see, I've got the episode title here, and all the other data is still from the original EP table. So we've done the first layer of deduplication or normalization. So let's look at the show data again. And what I'm doing here is show me the show ID, pull it from the episode table, episode people table, group by show, and show me 10 of them. Okay, and these are the different show names, but notice I got a show ID, and I can guarantee you all that data is unique in the show ID. So we're going to store that information elsewhere. So watch, here's the set of statements I'm going to execute where I'm going to actually pull the show data out into a shows table and use that to deduplicate and normalize. So I'm going to create the shows table here. I'm going to use the show ID as the primary key. Remember, it has to be unique. And what I need is the show title in the text. I'm going to use this statement here. It's a pipe statement there from the select. Actually, no, here's the select here. I'm sorry, I'm clicking wrong. This is the whole statement here. So I'm going to fill in show ID and show from this select statement using the group by, and then I'm going to print out the data so I can show it to you. I'm going to create an index on the show name. That's always going to come in handy. And then I'm going to show you the count from the shows table afterwards. Okay, so the count is 10,000. So there's actually 10,378 shows in this new table. So I've done, I've extracted the data. So now I'm actually going to pull the show data or deduplicate or normalize the data out of the new episode people table here. As you can notice, there's no show column here because I removed it to another table, and I will be able to join on show ID here. So first I create the table. I then do the insert into that table using the pipe select statement like this, where one, and that all just fills in really cool. And then I'm going to drop the original episode table, change the name of the new episode people table to the episode people table, and show you the first 10 entries. Let's watch it. Okay, and you can see I've removed the show title out of the entry. So I've just, if you look here, you can see that this episode people table is actually getting smaller and smaller because I'm doing proper normalization. I'm properly deduplicating data from that originally or badly organized table. But all the data is still there because I can get at the show title at any time by using the show ID over here. Next, I'm going to remove the person information into a people table. And so the way that, because that's all duplicated data as well. Excuse me. So create the table of people. Oh, it's executing, sorry. We'll have to go back here in a second. Oh, wow, it went way beyond where I wanted to go. All right, let's go back. All right, one of the advantages of doing this is you can run it again. Oh, wrong one. And we can just walk it through. So like if you screw up like I did, you can just walk the script again until it catches up to where you were. Well, we will have to pay the penalty of each statement though in the process, but it'll get us to the exact state we were prior. So bear with me here, sorry. Okay, this is the episode dates table. Okay. And those queries, okay, all the joins. Okay, the new episode people with still the show data. Okay, and I'm starting the process of removing the show data. There's removing the show data. Okay, this is where we are. Now I'm, oh no, I'm still removing the show data, sorry. Okay, now we're going on people. I apologize, but this is where we are. And so I'm creating the table people right here. It's going to have a primary key. Notice I'm using integer because most IDs you're going to use in database RDBMS are going to be integers. I just happened in the previous one to be using text ones, but most people will use integers, and we're going to use a concept called auto increment. So every time you put in a new row, it just increments the ID. So it goes 1, 2, 3, 4, 5, you know, so on and so forth, up to, you know, wherever you are in the number of rows. But don't count it on it as the row number. But it is guaranteed to be unique, and it's just the most common way to do IDs in RDBMS. But in here, the people database table is going to have the person name, the birth date, and the death date. I couldn't find a better name for the day they died, so I'm using death date. Sorry if that's offensive, but a lot of these artists no longer live, and the data was readily available, so I grabbed it. So I'm going to show this information, I guess, on that statement here, and I'm going to insert that data into the table as we've got it here. I'm going to create an index on it, okay? Then I'm going to show some of the data. I'm going to count the number of peoples. Then I'm going to go ahead and do the exact same thing with the rows. The row table is actually small, it's maybe a dozen. So I'm going to do this all. So I'm going to create the table rows with the role ID, an integer, auto increment, with just the role text, okay? I'm going to create an index on the role text, and I'm going to do the insert statement, count the data so I can show that to you. And then actually, since there aren't that many, I'm just going to show you the whole role table. So let's watch all this happen. Okay, here's all the role data. There aren't that many, maybe a dozen or so. So that's when it's allowed. Oh yeah, exactly a dozen. And so like here you got actor, actress, cinematographer, composer, whatever. Then in the people table, you're going to see the person ID, which as you can see is an incrementing integer for the ID because I said auto increment. And then here's the person name, Armadillo Slim. I don't know who that individual is, but I love their name. And then here's some of these people we don't know either their birthday or their death day. And I guess this person, Cousin Brucey, is still alive, whether he was born in 1935, but has a dash for the death day. So let's go on down here, go on to the next slide. So now we're going to take all that deduplicated data out of episode people. And so we're going to have a new episode people. It's going to just have that original date, which I'm going to, in a future slide here, I'm going to change the year. It'll have the role ID, the person ID, the episode ID, and the show ID, which is about as small as this table is going to get because I only need those pieces of information to get at all the other information. Now, again, I'm using an auto incrementing integer as the key. And here's my insert statement. And I'm having to use joins, a very complicated set of joins to make all this data work. But this is how I had to do it. So let's look at this insert statement very carefully. So we're going to insert the column date, role ID, person ID, episode ID, and show ID, okay? And I'm going to select from episode people, and I'm going to join on roles, okay? And the way I'm going to do it is I'm going to take the original episode people's role, which is in the episode people, and get the equivalent entry in the role table, okay? So I can then get, as you can see here, the role ID out of the role table. This is very complex, and I apologize. Well, if you can figure this statement out, you're very advanced in terms of SQL. So again, let's continue on with our joins because we joined it with that row. Now we're going to join it with another row. We're going to join it on the people table. Okay. I'm going to connect it on the person name in the original table EP and to the person name in the people table. Oops, I don't do that. That causes some of the problems in the people table, so that I can then go up here and say person ID is p.person ID or from the people table. Then I'm going to further go on and join with shows, and I'm going to connect the show ID from the episode people's table to the show ID in show there, and so I can get show ID from there. I guess I didn't really need that. That final join was probably not necessary, but you know, whatever. So then I will drop the table episode people and rename new episode people to be episode people. If you can figure that statement out, you're a winner. Put a gold star on your forehead because that's pretty complex. And I've done more complex than that, but you know, that's pretty complex. And so for a 101 student, you figure that out, you've got this thing going. So let's watch all that happen. Okay, so let's run a bunch of joins, or excuse me, a bunch of SQL statements here. I'm going to show, at first, I'm going to show just the first 10 elements of the new episode people's table. And I'm going to ask the question, are we done yet? And the way we're going to do it is we're going to look at these different select statements, and maybe we can improve it a little bit, and I'll show you in a minute. Well, actually, let's go over the SQL statements first here. Select from episode dates, join on episode people with the episode ID, because I actually have to get episode ID for, let's see here. I want to get the date. Yeah, that's what I'm doing. I want the, which is actually the show year from episode people. And so I have to join on episode ID in order to get the original year, okay? Then I'm going to join on shows so I can get the show name. Then I'm going to join on people so I can get the person name. And I'm doing the connection via person ID from EP to P. And then I'm going to further use a like statement, and I want to only get the entries where the date was on some September 8th. Year is not relevant. And, you know, September 8th is a really good date because it's considering it's my birthday. So, and then I'm going to sort by the date itself, and I'm only going to show 20 of them. The next select statement, I'm going to count those same entries, okay, of all of them though. Notice I'm not limiting. So the count should give all of those that are on September 8th of any given year. And then on this statement here, let's see what I'm doing here. I'm getting the date out of ED, getting the year out of EP, and the show name out of show. And you can see here, I'm connecting episode's date to episode people with the episode ID. And I'm connecting shows on the show ID based on September 8th, ordering in an ascending order, limiting by 20. Let's watch all that happen. Okay, so the first result, these are the first 20 entries of all shows given on the September 8th. Looks, it goes out anywhere from 1937 to 1950. Don't really know any of those names or any of those shows. So since they're before 1950, they're 10 years before I was born. So anyway, so let's go count all the entries in the table where a show was given on the 8th of September, and there's 6,000 entries right there. Then the other way, where I'm doing it in ascending order, right there. That's actually the same date as the first one. Okay, so now I actually, I see show data have been duplicated. And the reason why is because I had to connect everything via EP. And really, I don't really need EP for much. So I'm actually going to pull the data, the show ID data out of EP or episode people, because it's really associated more closely with the episode itself, because the episode and the show are right next to each other. So I'm actually going to do one further deduplication, and that is to remove the show ID from episode people and put them into episode dates. So in our standard pattern here, I'm creating the new episode dates, primary key. I'm going to do something called foreign key. What that means is I'm referencing the ID in another table. That other table is guaranteed that each row is going to have a unique ID. And a foreign key is saying I'm depending on this ID being in that other table. And in here, I'm saying the foreign key is show ID, and it's referring to the show ID in the table shows. And what that means is that you can't go into the shows table and delete the show ID of one that I've got in this other table, because I've got this foreign key constraint here. It's often called a constraint. And so now, okay, so that's our new table structure. And we're going to do our insert statement. We're going to have a join in there. It's rather complex. So let's look at this here. Not as complex as one of the previous ones, but the new episode dates is going to have episode ID, date, title, and show ID. Okay. I'm going to get the episode ID from EP. I'm going to get the date from ED, I'm going to get the title from ED, and I'm going to get the show ID from EP. I'm joining on EP, where we're joining EP to episode dates based on episode ID, grouping by episode ID. I will then drop the original episode dates, change the name of new episode dates to episode dates, create an index, and select, and just show you some of the entries and episode dates. That should be the final change I make to episode dates. And here we go. Okay, so in the new episode dates, I've got the episode ID, the date, the actual air date, the title name, and the show ID. So now I'm going to remove the show, remove the show ID from the episode people's table. I'm going to do some further organization here. Of course, we're going to have our episode people ID, which is an integer, auto-incrementing integer. But notice I'm using foreign key because 3 of those IDs are foreign keys to other tables. So I should really constrain them to be foreign keys. So the database actually helps by protecting you from deleting incorrect data. So the way this works is after I create the table, I can then run this relatively simple insert here because it's a single table. And it's just pulling everything but show ID into the new table. I drop the old table, rename the new table, and just show you the contents. Oh, and I guess I didn't mention it in the slide, but I created 3 indexes on the IDs that I had created. Again, that's going to help selecting or querying, making it faster. Okay, so now I can do the query without joining with episode people at all. So I can get the date of the episode and the show title without actually having the episode people table there. So I'm going to get the date out of episode dates, and I'm going to join it on shows to get the show title based on the show ID. Again, shows only on September 8th, and I'm going to sort it in ascending order and show 100 of them. And there you go. Whole, I don't know if there's 100, more than 100 or less than 100, but you can see it goes all the way up, it looks at least to 1982. And I bet you this one here is the David Letterman show. So I don't know all of them. That's probably the Tonight Show. Okay, so I've actually done all the transforms I plan to do. So one of the last steps I'm going to do is called vacuum in SQLite. Postgres also uses vacuum. Different databases will use other terminologies, but what it basically does is just cleans up the mess. Because every time I did a manipulation in that data, set of data manipulations, it created temporary data, expanded the file, further out, indexes, all sorts of things. So it never garbage collected. So I'm going to now, when I do the vacuum, I'm actually going to do what languages call garbage collection. But basically, I'm going to pack all the data. So I'm actually going to go back to the minimum size of the data file I need to represent the data as I've got it organized. The vacuum is going to run all 2 million entries or so it may take a moment. Okay, it's finished. And so now I'm going to show you the sizes of the 3 different files. Data set, which is the original CSV file, is 250 megabytes. And when I pulled it directly into SQLite without any transformations, it's 270 megabytes. Now, after I did all those manipulations, deduplications and stuff like that, I'm only 238 megabytes, not significantly smaller, than the original data set, but I'm a lot faster because most of that data in that 238 megabytes is actually the index data, which is going to help me in my select statements to let it perform much faster. So I have actually did some previous testing on this. And if I had not put all those indexes in, indices, I don't know which is the appropriate term in the SQL term, but it's only 120 megabytes if I did not put the indexes in. So the deduplication, the normalization really does a good job in compacting the data. But then I added the indexes to increase the performance. So again, it's an engineering trade-off. It is slightly smaller, but I would rather think of it as not smaller, but more performant. So yeah, that's basically what I just said. So let's look at some of the queries I could do after I've done all that indexing and stuff like that. I've got a complicated query here. Give me the show name, the date, the actual date it was in, and the person. First, I'm going, and I've organized this SQL statement on purpose in the way I've done it. Because what you do is you have your smallest, you want to have increasingly larger data sets as you go. It just seems to work more performant. If the data, the first table here is people, which is a smaller set than say episode people. And then I do have to join on episode dates, but because of the way I had to organize it, but because the people database or table is small, it's actually going to make this much more performant. So I'm going to say, okay, let's go on here. Let's talk about it. It's get me from the people table, joining on episode people as EP, where the person ID match. Then I'm going to join on episode dates, where the episode IDs match, okay? And then the shows, join it on shows, where the show IDs match. Everything is really coming out of ED because that is the central table now. It has most of the critical data there, but I still only want Fred Astaire and Fred Allen. And remember, there's only two here, so that makes expanding this out actually is going to be much more faster because I'm only expanding on two people. And that actually performed very quickly. It actually printed out as I typed it. I hit the return key. So I'm now done with the main talk. I'm going to talk about some postscript information, something on just other things to talk about. Selecting doesn't necessarily have to be selected from a table. You can just do a function. So in this particular case, I can select the data from a function. And so in this case, take this date. Remember, that's the form that we've got all the dates in the ED table, and add 3 days to it. That's what this date function does, and give me the response. So notice I'm not pulling from a table. I'm just returning the response from that function. Now, in this case, I am pulling from a table, but I'm going to say, give me the date 3 days in the future and the show based on the, where shows IDs match. And the date is September 8th, 2016. And show me that data. Then I've got two other quick selects here is Julian Day, which, by the way, my name is Julian, and I always love talking about Julian Day because it is cool. But it's really named after Julius Caesar, but there were several emperors also named Julian as well. But Julian Day here is basically take that date, 2016, September 8th, and turn it into an integer, which I believe is the number of seconds since 1970, the standard Unix epoch. I may be wrong on that. Could be milliseconds. I don't know. Could be database dependent. And then give me the Julian date for this date. Okay, and subtract the two and show me the output. And then just do a simple arithmetic, which is a simple division. So the first output here, you can see it went very quickly, and it's just that thing. And instead of saying September 8th there, 2016, it's saying September 11th, 2016, which is 3 days after September 8th. So that's what that, when you said date plus 3, wherever that is, oh, right here, date plus 3 on, oh, right here, date plus 3 with the ED date. Next, we did the Julian day arithmetic here, and we came out with actually looks like a real a floating point number, 17,000. I guess that's seconds, or it could be days. I don't know. And then just the result of the arithmetic. The column name is the piece of arithmetic, but the actual answer is 46. So I got one more. I got another query here. So give me the episode ID, the show, the date, the person, episode from episode dates, join on shows based on the show ID, join on episode people on the episode ID, join on people based on person ID, where the date is 11/18/1980. It's going very quickly because I've indexed those tables. Teledario, Star Games, Russell, whatever. And you can see these are all the shows because I had no limit. So these are all the shows that were on that particular date, November 18th, 1980. There's no significance that I'm aware of on that day. I just arbitrarily chose it. And that's basically everything I have to say about SQL. I fully expect you're going to have questions about just the things that I've talked about, especially some of those more complicated SQL statements. And so contact us. We can give you information on how, or I can give you further information on how to figure out those statements. But you can download that right here. That's how you download that file, and you can actually run that file as often as you want till you get, let's cell D, till you get more familiar with it, so you can walk it. And I recommend that you rock it in order, run me followed by section, followed by section. Now, at any time, you can rerun that SH file if you haven't done, if you've completed the first one in front of it. So make sure you've done the one in front of it, but you can repeat this one over and over again, or that one over and over again, so you can look at it. In the rest of the TAR, my notes when I was putting this together, SQLite, that's actually, I originally had this all as one SQLite script. Doesn't function well, but all the SQL statements that I've done are actually there in a notes form. And the 2 DBs that were created, and of course the original tarball. Since there aren't that many people in this, oh, there's a few people came in later. Anybody who wants to ask a question, feel free to ask right now. Just unmute yourself and ask, and then we can move from there. Okay.
Julian, I think a few of us were a little curious about, you had a where clause of just where one.
Right.
I'm not familiar with that syntax or use of the where clause.
Okay, let me bring up one of those scripts. 1 second. Move this to the side. Okay. Get to one of them. Okay, like in this one here where I say where one, that's an infinite loop. Okay, like right here. Is that what you're concerned about, where I just say where one, or just where itself?
Well, different spot, I think if the final clause was the where clause, and you only had where one, which didn't seem, I haven't seen it. I think someone else was asking about that too on Slack. So,
is there Slack? Hold on, let me go look in Slack.
I was the one that was asking about it. Yeah, I I was just wondering what you do it in a lot of places. I've just never.
Well, yeah, well, where one is actually not necessary at all. It would default to where one. I just did it because I just do it. It's syntactical sugar. The where clause in that case, if you say where one but don't type it, is implied as where one. Is that what you're getting at, John or Evan?
Personally, I've never seen that before.
Yeah, I've seen it before when people are auto-generating SQL, but I've never seen anyone actually type it.
Yeah, I just do it out of habit. But like I said, John, the where one is, it's basically an implied. In other words, go through every row in the table. Once it's a one pass through the table. Normally, you would put where and actually have some sort of conditional statement there, say like if the value is over 10 or something like that. But that is the extreme simple. It would be in. I don't know if I could do it. You could probably say where true. I won't swear by it because I don't know if that's going to be supported or not.
Yeah,
But it's basically an infinite loop or a single full pass loop.
in
That helps
Postgres,
you, Con? Oh, I'm sorry, Evan.
I was going to say in Postgres, where one would not be valid. It would require that conditional to evaluate to a Boolean, so that would just throw that off. But yeah, I mean, I've seen people do this type of stuff in like MySQL and in auto generation. I didn't know that was like a thing that for
Yeah,
syntactical.
no, I've always done it, so I don't know. Where one, I believe, is acceptable in Postgres. I do use this same form. Now, I might have said where true for Postgres, but that's one of the unfortunate parts of database is everybody's slightly different. And even though SQL is a defined language like Perl or Python or whatever, every vendor does something slightly different. And it can be very frustrating too, especially when it comes to the non-select statements like inserts, deletes, so on, drops, or whatever. They can be pretty daunting trying to figure out, okay, which database it is and Stack Overflow what the syntax is. Is there anything more I can help on that, John? Did it clear it up at all?
I was just kind of curious, like I said, I'd never seen it before, so.
Okay. So anything else?
No, you did good, man. Appreciate it.
Thank you.